Hey learners, welcome back to Constant Learners. In today's video, we will explore the key concepts and steps involved in designing an effective and well structured database. All right, we've discussed what is database. We also discussed in layman terms how exactly the database is created. The link to that video is given above as well as in the description box. If you watch that video, you will understand exactly what goes into designing the database, all right, and finally building it. But today's video is going to be more technical, all right, so let's dive in. Database design is a crucial process, okay, that helps organizations create and manage large scale data systems. The main goal here is to create a model of what? Of the planned database system. And why? So that the logic is implemented and the physical structure is identified. There are two things here. First, we have to identify the logic of the database system that we are creating, and then we have to put that logic to work. All right, but why exactly do we need a well designed database? So that there is consistency in the data, all right, and there's no redundancy. It is easy to manage the database in the future. All of these are characteristics of a good database system. So you can watch that video. We're not going to get into a lot of detail here. Now, let's start by understanding a basic of what a database is. A database is like a storage space where different types of data are gathered and organized. We've already discussed a lot about database and understood it. So, in this video, we are going to be more about how a database is supposed to be designed. All right. Now, database is a collection of information that can be stored and accessed electronically using computers. We know that we use queries and DBMS to communicate with the database, right? Now that we have a clear understanding of what a database is, let's explore the key aspects of the database design. Database design is a process that involves creation, then development, implementation, and maintenance. All right, so first we are creating the database, we are developing it, then implementing it, and maintaining it. Okay, both in terms of how it should work logically and how it should be physically structured. The different data elements in the database are connected. We know the data inside the database is related to each other, right? And thus we need to follow certain rules to design the database. Okay. Now, when we plan to build our home, what do we do? First, we think in our minds like what exactly are we planning to, build the house like, or trying to. If you're trying to renovate it, we will think like, this portion needs renovation. I need this here. I need that here, right? So first we plan it in our own minds. We discuss it with our families. Then we discuss it with the architect. Then architect builds a model, or let's say a blueprint of the design of our home. Then probably he'll build a model and then he will finally get to work and build the home, right? That is exactly what happens when we are building a database system. All right, the logical model focuses more on understanding the data requirements. So first the architects understand the data requirements and how the data should be organized. All right, this logical model is like a blueprint, okay, that does not depend on specific technical details. We'll get into the depth of what exactly a logical model is, what is physical model. This is just an outline of what a database system is made of. All right. On the other hand, the physical design model is about implementing the logical design in a practical way. All right. It considers things like hardware resources and software systems to ensure that the database runs efficiently and takes up the right amount of storage space. Now, developing a database system follows a set of stages known as the database development life cycle. All right. The database development involves multiple steps. First step in the database development life cycle is requirement analysis, which involves two steps. First is planning, and second is system definition. We'll get into the depth afterwards. Next is the designing process, wherein we build the data models. There are three data models that we are supposed to build: conceptual model, then logical model, and then the physical model. Once the three models have been designed, that is, our final database has been designed, we head to the implementation stage. So, the database is built using a specific database management system. This we will discuss when we get into the details of different models. All right. Now, after the implementation, the next step is data conversion and loading stage. And after the data is loaded, the database is testing, that takes us to the testing stage, right? If the database is functioning as per the user's requirement, our job is done and we only need to maintain the database, which brings us to the maintenance stage. And in case the database does not function as per the client's requests, then we again get to the requirement analysis and continue the cycle until our goal is achieved. All right. I hope that until here it was clear. Now let's discuss each step of database development lifecycle in detail. The first stage is requirement analysis. This involves identifying and understanding the fundamental requirements of the project. Okay, the database designers, they speak to the clients, stakeholders, and try to understand their business, their strategies, and their requirements. All right. Then these requirements guide the design of the database to develop a comprehensive plan for the entire database development life cycle, while considering the organization's functional requirements, that is, which operations they would like to perform on the data and what functions do they expect the database to perform, right? Now, this requirement analysis involves two other steps. First is planning, and the second is system definition. In the planning stage, the database design team interacts with the clients in order to understand the organization's business operations, the processes, policies, business rules, and focus on mapping out the entire database development life cycle. So, in the planning stage, the designers interact with the clients to understand their business, their requirements, and just make a simple mapping of the database development life cycle. Like they are trying to create a roadmap for the design process. That is how we are going to go step by step. Here we need to emphasize on organizations' requirements and align the database design accordingly. All right. Then we try to establish a strong foundation for the upcoming stages of the design process in the planning stage. Then, in system definition, we build upon the planning stage by defining the boundaries and scope of the database. That is, we need to understand what things are considerable, what requirements of the clients are considerable, what can be accomplished and what cannot. We set clear parameters and limitations for the database, like what it can accomplish and what it cannot, ensuring a clear understanding of its purpose and functionality. This helps us define what the database will cover and what it won't cover. All right. Next is the designing stage. This is a very crucial step of database designing. During this stage, our main focus is on creating a well structured database by carefully considering the requirements of the users. Okay. We break down these requirements into different models And we're doing this to distribute the workload and prevent heavy dependencies on one particular aspect. All right. So designing involves building the data models. All right. And the data models are simply the models or means to visualize and communicate the database design features at different stages of database development. The models are used to visualize the design, whatever we have planned in the planning stage, in the requirement analysis stage, whatever scope we have defined. Using different models, we are trying to visualize that design, and we are trying to build on that plan and finally get to our structured database system. All right. It helps them to understand the database design requirements and if the database is being built in compliance with those requirements or not. All right. Now, there are three models that we build in the designing stage. First is the conceptual model, second is the logical model, and third is the physical model. Let's discuss each of these quickly. In the conceptual model, it provides us with the user's view of data. All right. That is how the client or the organization wants to look at data. So we try to look or we try to visualize the data from the user's perspective and try to plan how we are going to plan the data into different entities. It provides us with a conceptual schema highlighting the database entities. So, in the conceptual model, we are planning the entities. What are the entities? Entities are nothing but any real world objects or real world things are entities. All right. For example, in a hospital database, we can have hospital staff as an entity, then departments can be another entity, then patients can be another entity, and doctors can be an entity. So, we define the entities inside the database, and these entities are defined in the conceptual model. This is a very abstract or superficial view of data. That is, everything that we are getting in the conceptual model is a very abstract or superficial view of data. This does not provide us with any depth. All right. It's easy to create as well as understand. No special software is required to create the conceptual model. Next is the logical model. The logical model is constructed by expanding conceptual model. All right. It is a crucial stage in the database design process that is built without considering specific database management system or physical implementation details. That is, even in the logical modeling stage, which database management system we are going to consider, it does not make any difference. All right. So, whatever database management system we are using, we can think about it after completing the logical model. It will not make any difference. We need to understand that everything in the logical model is a concept. It's a thought. It's a theory. All right. That becomes a reality in the next step. That is in the physical model. Here we are only discussing the theoretical part, the conceptual part of the database design. Okay. Now we've already identified the entities in the conceptual model. All right. The hospital staff and the departments, patients, doctors, those were the entities. In the logical model stage, we take one step forward and focus on understanding the needs of the data. We determine how different elements or different data elements relate to each other and what information should be stored in which tables, right? Then we make decisions about how the entities relate to one another. This is what we're talking about, how the hospital staff table will be related to or connected to the department table, how the department table will be connected to the doctor's table. So that is what we need to look forward to in the logical model. Now let's discuss the key features of a logical model. We identify and define the entity relationships in the logical model. All right, that means how the entities are related to one another. Then we specify the attributes that describe the characteristics or properties of each entity, that is, explain each entity. That means hospital staff will have all the details about the about each and every hospital staff. It includes the wardens, the nurses, the doctors, the admins, everyone. All right. Then we assign a primary key to each entity for unique identification. We've already discussed this in the previous video. All right. Then we try to establish relationship between entities through foreign keys. We've understood that hospital staff will be connected to the departments, but how will they be connected? Which one will be the primary key for which table? Which foreign key will be available in which table? That we need to define. All right. And then we apply normalization techniques to eliminate the redundancy and ensure data integrity. We are going to discuss normalization in a separate video because it's a very important concept, all right, that we need to understand. Now, in the conceptual model, the entities have already been identified. In the logical model, we define the primary keys. Like, for example, for these tables, these are the primary keys. And then we define the relationship between different entities. That is, hospital staff will be related to hospital department. It will also be related to the doctors, right? Then doctors will also be connected to the patients. Doctors will also be connected to different departments, right? So we are trying to build a relationship between different entities in the logical model. And we also define the foreign keys to relate the entities, because see, this hospital staff table will have its own primary key. Then it will have another column which will be the foreign key. Like this hospital department is the foreign key which is coming from here. Hospital underscore docs is the foreign key which is coming from this table. So this is the primary key for doctor's table, but here it becomes the foreign key. So we declare the primary keys, the foreign keys, and the relationships between different entities in the logical model. Next is the physical model. Once the logical model is established, we move on to the physical model stage. The physical model focuses on implementing the logical database design, considering factors such as chosen software systems, database management system, the hardware resources, and physical implementation aspects. So, the database management system is considered in the physical modeling stage. This stage brings the database design to life by transforming it from a theoretical concept into a practical implementation. All right. This step actually determines how and where the data will be stored on physical space. Now let's discuss the key features of physical data model. Now we've already specified the entities in the conceptual model. In the physical model, we declare the tables and specify the specification of columns. That is, we define the structure of tables, including column names, data types, constraints, etc. Then we declare the keys, and with respect to those keys, we declare the relationships among tables, right? We need to understand that everything we did in the logical model was a theory, a concept. However, in the physical model, that theory is coming to life. We need to consider the physical and practical aspects of the database design, which might lead to potential differences from logical model. That is, in the physical model, when this design is being actualized, when we are actually building the database, then the model, the physical model, could be different from the logical model. All right. Then physical models can be different with respect to different relational database management systems that we are using. All right, including the differences in data types. So it all depends on which RDBMS we are using. Now, what happens when the logical model is converted, or the physical model is built? First, the entities that we defined in the logical model gets converted to tables in the physical model, right? Then we define some relationships between the entities. That is, actualized using the keys, right? We declare the keys because everything is being built in the physical model. In the logical model, everything was a theory. So whatever we declared or decided or thought about in the logical model is actually happening here in the physical model. So we declare the keys, we define the tables first, we declare the keys, that is primary key and the foreign key. We also declare the attributes. We define some attributes in the logical model for the entities, that is what kind of data it will store and how it will be related to other entities, right? In the physical model, we define the columns and we define the uh, proper attributes, that is what kind of data types we are going to have for that particular column, what should be the length of the data inside that column, whether it can be null or it cannot be null. So we define all the attributes in the physical model. Now, modify the constraints means what? We have created some theory, some concept in the logical model for our database, right? Let's say in the logical model, we thought that a particular column in a particular table can stay empty or it can stay null. But when we actually started building the database in the physical model, we identified or we understood that this column cannot stay empty. So, what are we doing? We are modifying the constraints that we defined in the logical model to meet the physical requirements of the database in the physical model. All right. So, all of these changes take place from logical model to the physical model. Comparing the physical data model to the logical model, we observe several differences. All right. Entity names become table names, attributes become column names. The physical model specifies data types for each column based on chosen database management system. The actual database implementation influences the data type definition in the physical model. All right. I hope that this was clear. So, in the logical model, a lot of things are already decided or thought about or discussed about, but in physical model we are just putting it into action. All right, I hope that this was clear. Implementation. During this stage, our main focus is on putting the designed database into action and ensuring that it meets our requirements effectively. Now, to achieve this, we engage in continuous integration testing. That is, we're using different data sets to ensure its functionality and performance. We also convert the data into a format that the computer can understand and process efficiently. During implementation stage, data manipulation takes the center stage. We write and execute queries to interact with the database and assess whether the application has been designed satisfactorily or not. All right. After implementation stage comes data conversion and loading stage. Now, in relational database design, the data conversion and loading stage plays a crucial role in smooth transition from previous system to the new database system. Let's say the company is an old company. So there must be some data, right? So we need to transform the data from the previous system to the new database system. We need to transition. All right. So this stage involves importing and converting data from the old system into the new database, ensuring compatibility and adapting the existing data to fit the structure of the new database. All right. It ensures a seamless transfer of data, allowing for a successful migration from the old system to the new one. All right. The next stage is testing stage. Following the implementation stage, we move on to the testing stage, which plays a crucial role in ensuring the accuracy and functionality of the newly implemented system. During this stage, a thorough examination of the database takes place to identify any errors or discrepancies. The primary objective is to validate the database, that is, whether it meets the specified requirements and functions correctly or not. Through rigorous testing, we can verify that the database aligns with the desired behavior and fulfills the expected criteria or not. This stage acts as quality assurance measure, assuring the accuracy, reliability, and effectiveness of the database. In case the database is not working as per our requirements, the team will again go to the requirement stage and the data development life cycle will continue. All right, the cycle will keep on going until the satisfactory database design has been designed. All right, and if the database has been designed perfectly, then the only responsibility left will be to maintain the database. So that was the end of the database development lifecycle. But before we end the video, let's quickly discuss why database designing is important, right? Now, it is important because it acts as a blueprint for storage, for data storage in a system. It greatly impacts the application performance. It provides an insight to how an application would work and how the requests will be processed, thus ensuring an efficient and effective data management system. User requirements are considered and met by incorporating user needs into the design, which in turn makes the database more user friendly and functional. Implementing an efficient database design can significantly reduce the application processing time. When design constraints are properly implemented, the application runs smoothly and quickly, resulting in improved performance. All right. By understanding and prioritizing these points, we can create optimized applications that meet user requirements effectively. I hope that this was clear. This was all for this video. In the next video, we will discuss the architectural design of the database systems. And if you like the video, please give it a thumbs up. Share your thoughts about the video in the comment section. If you have any doubts, any problems with the videos, any problems with my explanation, please share it in the comment section. And if the video helped you, please give it a thumbs up, share it with your friends, and subscribe to the channel. Thank you so much for watching.